So we look into this question called vowels of all substrings. This is still level 1 questions. We are not going into the level 2 questions as yet, but yeah, this is like more algorithmic level 1 question. The previous one were more OOP level 1 questions. Okay, cool. So given a string word, return the sum of the number of vowels in every substring of word. So in every possible substring of word, you need to return the sum of the number of vowels there. Okay, and they're telling you in advance, due to the large constraints, the answer may not fit in a 32-bit signed integer. So make sure that you be careful. Basically, we'll need to use a long over here to get the answer. So the example they've given is ABA. Let's have a look at this example over here. So vowels of all substrings. Right. So one second, we'll look at this. Vowels of all substrings. So the example they're given is ABA. Now, what are all of the possible substrings of this? You can have A, you can have AB, you can have ABA, you can have B, you can have BA, and then you can have A. So there are totally 6 substrings, right? If I look at it, it's like A, AB, ABA. Then you could also have B, BA, and then you can have just A over here. How many vowels are there in this one? There is one vowel here. If I just keep it on the side, there's one vowel here, another vowel here, 2 vowels here, 0 vowels here, 1 vowel here, and 1 vowel here. So totally, if I add the number of vowels, I get 1 plus 1, 2, plus 2, 4, plus 2 more, 6. So the answer becomes is equal to 6, because there are if I combine all the substrings, there are 6 vowels totally in all of the substrings combined. All right. Okay, so over to you guys now. I'll give you one example and you have to tell me how many vowels are there in that. So tell me in A, B, U, C. How many vowels are there in all the substrings of this? How many vowels will be there? Or how many sum of the vowels? Like if you take every substring, what is the sum of all the vowels in all the substrings combined? Let me know. What do you guys think? How many will be there? Think, everybody, take about a couple of minutes and think. 10. Okay, somebody is saying 10. What about others? Do you think it's 10? 10. Okay, let's do it this way. Okay, A will be with itself. The way to look at this question is where all A will participate. Okay, A is going to participate on its own, and it's going to participate with another 3 more. Right, so it's going to come AB, ABU, and ABUC. It's going to participate with that. So A is going to be part of, let's say, 3 with itself, and then 3 more on the right side. So A is going to be part of 4 substrings over there. All right. What about U? What about U? Because that's the only other vowel that you have here. So what about U? U will participate. One is on its own, right? One is on its own. Plus, it's going to participate with basically, how do I say this? Yeah, what will U participate with? What is U going to participate with? U will participate like this, UC, right? With BUC and with ABUC as well. So in other words, we can also look at it this way. After U and before U. Before U, you can participate with 2, right? Before you can participate with 2. And after you can participate with 1. But all the ones that you participated with before 2 can also be counted later on as well, right? Let's think of this a little bit more. And through this only we'll get our logic. U that's there, right? How many substrings can it be part of on the left side? On the left side, it can technically be part of 3 substrings, right? How do I mean by 3 substrings? You have A, you have AB, and you have ABU, right? All of these are possible, right? Again, let me just rephrase. It could have started from A and come to U. It could have started from B and come to U, or it could start from U itself, right? So these are all the ones that it could participate in from the left side, plus its own self. These are all the ones that are possible over here on ABU. These are all the ones that are possible. Okay. Am I double counting? Yeah, I am double counting. I'm double counting. So again, let me just say it here. Let's again look at A, B, and U. What are all the possibility on the left side? If we get the left side correct, then the right side is actually quite easy, right? So if I just look at the left side, U can participate with starting from A, starting from B, right, and itself, right? Starting from A, starting from B, and starting from itself, right? So that would be that it is 3 are there that it can do, right? Now, let me look at it the other way. Actually, let me look at it like this. U can be the end of either if it started from A or if it started from B. So there are two possibilities over there. Okay. So somebody's saying, sir, for both A and U. Yeah, we'll get into it. For A, it was easy because it's starting with A. So we know that A will participate in 4 of them. What I'm trying to do here is I'm going to say that where all is A appearing? I'm not trying to generate the substrings themselves and counting the number of vowels, but rather I'm trying to say where all will A appear in all those substrings. In how many substrings A will appear. That way I can count the sum of the vowels. That would be easier rather than generating all the substrings. Because generating all the substrings will take too much time. Right? So here what I'm saying is U could either have started from 2. It could have U could be the endpoint for any of the substrings on the left side, which are there are 2 substrings on the left side, right? Plus its own, right? There's its own substring as well that it can have, right? Into, why am I doing into? Let's say there was a D, E, F over here. All of the substring on the left side will combine with, let's say, up till C, then up till D, then up till E, and so on, right? So what I look is how many substrings do I have on the right? I have 1, right? So as per this, I would think that I have like 4 plus 3, 7 substrings in which I'm getting. Is that correct? If for A, B, U, C, I'm getting 7 substrings. Would that be correct? We'll only have to find out by generating all the substrings, right? So let's quickly do that. A, B, ABUC, and is it ABU and ABUC is the one. Starting from B, you have B, BU, BUC. Starting from U, you have U, UC, and then you have C. These are all the substrings that are there, right? We don't want the subsets. We don't want all the things. So you have this. If I'm doing that way, so you get 1 here, also 1. Here you get 2, and for ABUC also you get 2. Right, then B is 0, 1, 1, and then you have 1 and 1. So it's definitely not 7. It is 2 plus 4, 6 plus 4, 10. Yeah, so you guys are right. It is 10. 4. Yeah, it is 10. So we're missing out some place. A, okay. Are we correct in saying that A is participating 4 times? Let's look at it this way. A participates 4 times. Yeah, A overall is participating 4 times. It's not participating more than that. Is our count for U correct? U comes 1, 2, 3, 4, 5, 6 times. And we were thinking it's coming 7 times, right? So where did we make a mistake? We said that U will either be part of all the ones that end in U. So if I look at it, the ones that end in U are these ones. The ones that end in U is, this one over here. That's one of them. This ends in U. This also ends in U, right? And this also ends in U, by the way, right? And we said all of this will all combine with C on the right side. Yeah. So I have C on the right side, C on the right side. Oh, where we made a mistake was it's not just C on the right side. It is adjectives themselves have to be counted plus C on the right side. That's where it got mistaken. Meaning that you count your own self, there will be, so in other words, all the ones ending with U, all the ones ending with U will be 3. There will be 3 ending with U plus 3 into how many ever elements you have on the right side, elements on the right side, which will also contain u, right? So how many elements are there on the right side? There are actually just 1 on the right side. So u will be 3 plus 3, which is equal to 6, and then you have 4 plus 6 as 10 overall. Let's take one more example so that we all are on the same page. So for instance, let's apply the same logic to ABA only, right? Let's apply the same logic to ABA. What I'm saying is, instead of generating the substrings, let's say that, okay, starting A is the starting part. So what we are saying is that A itself is going to combine with 3 substrings. That's simple because it's the starting one. When it comes to the next A, we are saying that the second A, it is going to combine with 3 before it, because it can be like A, it can be ABA, BA, or just A. So it could be 3 before it, into, first of all, themselves, plus 0 on the right side. I don't have any other on the right side. So this totally would be 6, which is what we got. We got 6 as the answer. Let's take another example to get the entire flow of this. So let's take BOARD. Let's say something like this. Okay. B is not a vowel. O is a vowel. O will combine with 2 from the left side, including itself, 2 from the left side. So it's going to be like BO and O itself. This will be themselves, like these on the prefixes themselves, plus every element on the right side. How many elements do we have on the right side? We have 3 elements on the right side, right? So O is going to be part of 8 such substrings. What about A? A is going to be part of 3 from the right side, 3 from the right side over there, into first itself, plus how many on the 2 on the right side, which is going to be equal to 9. So totally speaking, you should have 17. You should be having 17 such substrings in which vowels are there. And we can confirm this also. I think let's quickly just create all of them. So it'll be B, BO, BOA, BOAR, and BOARD. Then you have O, OA, OAR, OARD, A, AR, ARD, R, RD, and then D. Right? These are all the substrings. Now let's check for them. You have, if I again make the same kind of a thing, so let's put that over here. It will be basically no, B is 0, 0, comma, BO is 1, BOA. So BOA is 2, 2, 2. For O, you have 1, 2, 2, 2. A is 1, 1, 1, 0, 0, and 0. Right? So if I count the entire thing, it should become, if I sum this up, it is 6, 7. This is also 7. And here you have 3. So overall, we got 17, right? Is equal to 17. Are you understanding the working of this one, everybody? What's the working of the solution? I'm basically trying to say that, see that for this vowel, how many from the left side will I be part of? So those are there for sure, those substrings. And how many of these left side substrings will then further be continued on to the right side, right? So it's like saying for A, what are all the substrings it's going to be part of? I'm not generating all the substrings, rather I'm saying what all substrings is going to be part of. It's going to be part of B, so it's going to be part of BOA, OA, and A. So these 3 you have for sure. And then on top of these 3, it is all of these will further extend to R and then further extend to RD. So there are 2 more for each of these 3. That's why 3 into 2 you have over there. Is this part clear, everybody? Are you guys getting what we're trying to say here? Is this clear? Please do say clear on the chat so that I know it's clear. Right? Okay. Awesome. Clear then. So I'll just go and implement this. So the way we'll do that is we'll write this entire thing. What you have is input is just one word. You have one word. So that should be public class main, public static void main string args. And you have to also add the scanner. So you do import java.util.scanner, and you do scanner scan is equal to new scanner system.in, and you did string word, and word is equal to scan.nextInt, right? This is what we do. Now all we're trying to do is we're trying to go through this entire word. So I go for int, we can also do anyway, for int I equal to 0, I less than word dot length, I plus plus, right? I try to get the current string right now. So I say string current is equal to word of second. So I get word dot get I comma I plus 1. This is a way of getting the string at the substring between at position I. So I got this. Now I say if is vowel, I'll write another function called vowel. So is vowel, current. If it's a vowel, then what do I want to do? I'll create the int total, the total sum of it. So what I'm going to do is I'm going to check how many elements are there on the left side, including my current element, right? So that's how many pre-substrings I'll have. So int pre-subs is equal to how many? It's going to be like if O is at, if A is index here, it's going to be 3. So basically if it's at index 2, so it's going to be index 2 plus 1, right? So it's going to be I plus 1, right? That's how many prefixes it's going to be part of. And the number of suffixes that it can combine with, int suffixes that it can actually combine with. So I'll make this also prefixes, int prefix and int suffix. Yeah, sorry, it should not be next int, it should be just be next. Yeah. So in suffix, number of suffixes it can combine with is n, n being the length, right? So it'd be word dot length minus I. Is that correct? If I just look at it, what are the number of suffixes it can combine? 0, 1, 2, 3, 4, and it's n is 5, right? N is equal to 5. So it can combine with 5 minus 2. No, n minus I minus 1, right? Technically speaking, it's going to be n minus, this is 2. It can combine with n minus I minus 1, I believe. So that you get 5 minus 2. But we want to do plus 1 also on that, right? So it can combine with how many on the right side? 2, including my own. So what we want to do is total is equal to total plus how many will this combine with? This will combine with prefix into 1 plus suffix. Why did I do 1 plus suffix? It's like all the prefixes themselves will be there for sure. So you count all the prefixes on their own, plus all of the prefixes will then combine with the suffixes as well. So that's why I did this. So total is equal to total plus that. And then finally, I should print out the total. Here. Right. So if I run this, all right, sorry. Word dot not get, word dot substring. I am messing up the syntaxes. So word dot substring, and we didn't do the is vowel. We didn't do the is vowel method. So let's quickly do that. Public static boolean will return true or false. Boolean is vowel. String, let's say x. We want to check if x is a vowel or not. So I just do if x dot equals a, return true. There is a cooler way of writing this. I'll also explain that as well. So a cooler way of writing this would be there, but so this is one way. Actually, yeah, we can, instead of so many, let's just do this. X dot equals a, or x dot equals e, or x dot not equals also, by the way, equals, no, equals is correct. E I O So if it has any of this, you return true, else you return false. That's the vowels. So string out of bounds exception. Why do we have string out of bounds exception over here? I comma I plus 1, not I plus I plus 1. Made a mistake there. All right, so now it passes the test cases. And if I submit it, it passes. Not all the cases, it passes only some test cases, but not all. Why does it not pass all? Because as you always go back to the question and check out, as per the question, it says that due to the large constraints, the answer may not fit in a 32-bit integer, right? So if it doesn't fit, we will need to create a long int. It's in Java, it's long, right? Or is it long int? This part I don't remember. Long is fine. Okay. Yeah, it is. This also should be long ideally then. Long and long. And then all of these are long, by the way. Right. And let's just see. Lossy conversion. All right, fine. This could be int. That's not the issue. Yeah, but yeah, no, it passes. Correct. So you needed the total number of suffixes and prefixes also to be in long. That was the issue. So yeah, the edge case over here was that both basically the total number would be too big. So hence we had to make it into a long value. Okay. Is this one clear, everybody? Did you all understand? So it's a simple mathematics. Actually didn't have to do anything too much. Some of you I know were trying to do DPE and all with that. You don't really need to do any of that. It's just simply mathematics over here.